So lesson 2 begins on page 13. It really begins, no, actually page 14. Begins on page 13, but we'll be on page 14. All right, so let's take you back. Let's go back in time. Anyone got some back in time music we can do? No? Thank you. All right, thanks. Okay, so we went back in time to, I don't know, 2nd grade maybe? We've gone back a little ways. So, 2nd grade, yeah, we'll call it that. We've gone back just a little bit. And in 2nd grade, you learned something like this. And one of the things you learned was what's called inverse operations. Now, we start back in Saxon math because in Saxon, we just build. And we continue to build. And by the end of the year, we're going to be doing hard stuff and all that was pieces of easy stuff put together to make a single thing. So that's kind of how Saxon math works. Instead of doing a concept and then throwing it away, not touching it the rest of the year, we're always seeing stuff as it gels together. All right, so inverse operations is something that we are going to take a look at. And I know we can go back to 2nd grade at least because my son was doing this last year. All right, so inverse operations work like this. First off, tell me the answer to this simple problem. 2 plus 3 equals 5. So, wow. When I do the inverse of something, what does inverse mean?
Opposite?
Yeah, roughly, yeah. We'll say opposite. Okay, so what is the opposite of addition? What undoes addition? Subtraction. You can just tell me. So subtraction undoes addition. So if I were to undo this problem, I could say 5 minus 3 equals 2. I could also say 5 minus 2 equals 3, right? I can undo these problems. That is an inverse operation. So remember, let's pause this for a second. Back to where we were. All right, so those were inverse operations. We can undo a problem. For example, here's another one. 5 times 3 equals 15. And 15 divided by 5 equals 3. Those are inverse operations. I just did the inverse of what I was doing. So moving on, let's write down some terms. And yes, I'm just reusing the screen I used with the previous group because it's easier that way. So here we go. All right, so let's just take a look at this first one here. The commutative, you can't ever say that, property of addition. Okay, don't worry about the rest of it. We'll do that. I'm just going to piece this together. So this should go in your notebook, this first part here. I'm going to change my color so you can. All right. Oh wait, I got to use my football season's coming, so I'll change my color to match my team colors. All right. So what this property is telling us is the order I do a problem in does not really matter when we're talking about addition. I can add any 2 numbers and get an answer, reverse those 2 numbers that I added, and still get the same answer. 3 plus 5 equals 8, so does 5 plus 3. That's all that property is telling us. It's a term, though, and it shows up a lot. Even when you're a junior or senior in high school doing an ACT test. What is the commutative property of addition? Huh? I don't know, I haven't done that in a while. Well, you better know. So these things do show up. All right? The same thing applies to multiplication. I can multiply 2 numbers. I can change the order of those 2 numbers and still result the same answer. 3 times 4 equals 12. Well, so does 4 times 3. Okay? These will still give me the same answer. That's what this property is telling me this. Now, this does not apply to subtraction or division, because if I do that, if I change the order, I'm getting a different answer. So it does not apply to subtraction or division. That's why the properties are listed as addition and multiplication. So take note of that so you have that concept down, because I've seen that concept get mixed up a little bit. So moving further, ooh, too far. Let's get back. Come back. Come back. Come back. Okay, the associative properties. And they apply for addition and multiplication as well. The associative properties are going to tell me the same thing, but with parentheses. I'm going to use parentheses because if you know anything about order of operations, when you use parentheses, you do what?
You do the thing with parentheses first.
Yes. So the parentheses are going to tell you what to do first. And no matter where I stick my parentheses, I'm still going to get the same answer. So, for example, 3 plus 2 plus 4. 3 plus 2 is 5. And 5 plus 4 is 9. And then I do it in a different order on the other side of the equal sign. 2 plus 4 is 6. Plus 3 is 9. So I changed the order, still got the same answer, right? Yeah, that's a very simple problem. So it's just an example. We'll do a little, not hard, but we'll do another one to kind of help us through that. These are terms, and hopefully this should be reviewed. Okay, this should be reviewed for most of you. I don't know about all of you, but definitely most of you. All right. Same thing applies for multiplication. I can use the parentheses to change the order and still get the same answer. 3 times 2 is 6. 6 times 4 is 24. 2 times 4 is 8. And 8 times 3 is, guess what? 24. So we can still result the same answer when we are doing that. There's another property that applies to addition and multiplication, and that is the identity property of addition and multiplication. There are really two properties. I just lumped them together because I don't want to keep writing identity property. All right, so if I'm adding something, if I add 0 to anything, I get the same answer, correct? 5 plus 0 is still going to give me 5. 5 plus 0, not time. All right, so if I add 0 to anything, I'm still going to get the same answer. All right, because you're not actually adding anything to what you had. If you had 5 apples and I gave you 0 apples, you still have 5 apples. The identity property works the same way with multiplication, except for a different number. If you multiply anything times 1, you still have what you started with. 5 times 1 is always going to be 5. A billion times 1 is always going to be a billion. All right? And then finally, the last property, and we're going to be done with our terminology, is the 0 property of multiplication. 0 property of multiplication tells us if I multiply something by 0, I get 0. So whatever I multiply by 0, I'm still going to get 0. Not too hard. Because I'm not actually having anything at all. All right, questions on that stuff? That should be fairly easy. All right, so let's do a little thing. I'm not going to call on names, you just tell me the answer. Which property is this? Five times 3 equals 3 times 5. Yes, sir.
Inverse operations.
That's not an inverse operation, no. Yes.
Commutative.
Commutative property of multiplication. You can abbreviate it when you're doing your assignment, but make sure you say of multiplication or of addition, because there's two of them. Make sure it should be obvious, but still. All right, so what about this one? It's some parentheses, 3 plus 4 plus 5 equals 3 plus 4 plus 5, but with different parentheses, different places. What property is that? Just tell me. Okay, associative property of addition. Okay, so here's another one. 6 plus 0 equals 6. Oops, I don't know how to write that. What is that one? Identity property of addition. Okay? Make sure you know these terms, because when we get to our first test after lesson 10, man, guess what? They're going to be on it. And it's a real quick answer, but I've seen enough students get them wrong because they're like, oh yeah, I got this, and then they get to the test and they come to me, I need help. I'm like, well, how can I help you? Well, I don't know the name of this property. Nothing I can do for you. You just need to know them. Okay, doke? All right, so let's do one more thing. You will be asked, and I did this with the other group, but I'm going to do a different problem. You will be asked occasionally, actually it might be the same problem. You will be asked occasionally to justify an answer. When you justify something, you are going to give evidence for what is going on. In math, when you justify them, you are going to list out the steps and what you need to do those steps. Okay, so here is an example. Here is step 1 for this problem. It's a real easy step. So I would write this down because you're going to have to do this at least 4 or 5 times. Step 1 is, that is my given problem. That's what I've been given to do. Okay, so step 1's easy. It's given, the word given. That's what they gave me to do. Okay, I don't want to do it, but that's what they gave me to do. Why? Because whoever wrote the book, that's what they gave me. All right, here is your next step. So I'm going to write down the problem. You're going to tell me the step that was involved to do this. What is the step? It's one of the properties that you have written down.
Inverse?
Not inverse. Inverse is only if instead of multiplication, I'd be doing division.
Commutative.
Okay, commutative property of. Okay. Okay, so I'm just, you can write it just like this in your on your assignment. I just shortened every word down. Okay? Commutative property of multiplication, because I changed the order inside the parentheses. All right, so here is my third step. All right, so what property did I do this time? I physically moved my parentheses this time. What's that property? No. Look at your list. I'm still multiplying, I'm not doing division. Division's the inverse of multiplication. What is it? The associative property of multiplication. Very good. Okay, associative property of multiplication. Change the order of what I did. Now, I'm done with the properties, but there are 2 more steps to do. Okay? When you get into geometry, when you reach that point in your career, you might get a problem and it says, give us the proof to this problem, and you end up writing half a page explaining the problem. All right? This is a much more condensed version of that, but this is kind of like a baby step towards what you'll be doing. All right, so number 4. What did I do? Oops. Let me erase that. I wrote the thinking ahead of myself. What did I do to solve this one? There's no property to list. What did I do? Tell me. No, I did not. Where did 100 come from? What did I do to get 100?
4 times.
Okay, so I just did 4 times 25. Okay, that's all I did. I'm just saying what I'm actually doing. Okay, that's the one different thing I did on this one. So one more. Here's my answer. What did I do to get to my answer?
You multiplied 100 times 5.
Times 15.
I mean 15.
Yep. Okay, so that's just me stepping through the problem, step by step. Any questions? We are still simple, but what's interesting about Saxon math is we'll get to a point where some of you are like, this is so easy, and some of you are like, oh, this is getting hard. Some of you are like, whoa. That's when you need to talk to me and speak up. All right? And if we're still like this easy, then we'll decide what to do after that. But some of you you'll be at different points when the wall comes, and then we'll decide what we need to do at that point. Any questions? All right.